All right, now let's look at the elimination reactions. The elimination reactions don't necessarily have a set family that it has to happen, although typically it's the alkanes, and I would say probably 95% of the examples I've ever seen have been alkanes. Doesn't necessarily mean they have to be the alkanes, though. That's just by far the most common. The easiest way to think about elimination reactions, though, are that they're the opposite of the addition reactions that we covered. So instead of adding two molecules to a multiple bond to make it more saturated, we're going to be removing two things and creating a multiple bond to make the molecule less saturated. So typically these will start with one product, although there's an example where we're going to have two, and we're going to remove something off of it and create a new molecule as a product on the other side. So let's jump into an example here. If we start with a propanol, propan-2-ol, like this, in an elimination reaction, they quite often have acids or other catalysts that are used, so you don't necessarily need to know what catalyst would be necessary, just like with the others, but they're quite often there. In this case, we're not adding anything onto it, so there's no other reactant, but we're removing that hydroxyl group. It's going to come off before one of the just H's. But we also have to remove something from an adjacent carbon. So I can't remove that H. That's not an adjacent carbon. That's the same carbon. But I could remove an H from here, and those two together are going to form a molecule of water. And since we've removed those things, we're also going to end up with our parent molecule, but now there's a double bond on there. Let me fix that. It's going to bother me. Yeah, now it's going to be like that. Now we've formed an unsaturated molecule from our original saturated molecule, and we've also got this water molecule there. If we had a propane again, like this, so let's make this a chloropropane. Sometimes in the presence of strong base. Now I showed this also with substitution reactions. You'll never be asked in Chem 30 to know whether it would do a substitution or an elimination. But you might get shown the reaction and asked what's happening. So sometimes in this case, the chlorine will be removed, and still the H is going to come off. Where they go, though, is what changes a little bit. And what ends up happening is the H and this hydroxyl, or hydroxide, I should say, hydroxide, they go off together and form a water molecule. We get our unsaturated propene, like that. But you've also got that chlorine that came off. So there's also a plus Cl negative that's left over here. Now, again, I'm never going to ask you to look at this and know the specific conditions of temperature and pressure and catalysts that would lead to an elimination or a substitution. But if I showed you that reaction right there, you should be able to tell, oh, we started saturated, we ended unsaturated. That's elimination, not substitution. The last example I want to show you on this is one where there are multiple possible outcomes. So if we started with a molecule like this, a butan-2-ol, and we do an elimination, so OH2SO4 maybe is the acid that's present. There are options, because we could remove this OH with this H. That would give us a 1-ene. But you could also remove that OH with that H, and that would give you a 2-ene. So again, just be aware that you could end up with a propan. Let's do the 1-ene first, like that. Or you could end up with a propan 2-ene like this. And either of those would also still have that molecule of water that was removed. That would be there just hanging out. So that's the elimination reactions. It's, if you understand the addition reactions really well, it's looking at the same thing essentially in reverse, just some things coming off, with the exception of that strong base one being there. I think that's about it. If you need some more practice or you need some more help with this, just let me know and we can go through some more problems. But that at least covers the basics of what you need to know. So hopefully that helps.